Hello, and thank you so much for joining me today. I'm going to tell you about a journey of using Nomad to get from zero to production. And we're going to do this at extremely high speed. Let me give you a little bit about myself first and why I'm somebody who does this kind of work. So I play with what I call infrastructure Legos. And in fact, this is how I think of most software that's out there. There's the drawing that's on the side of the box, and you could build that, and that'll be fun. But you could also take the set apart and build other things with it. And that's what I'm doing today here. So some projects you might have seen my work on. I work on a Linux distribution called Void Linux. We're a rolling release distribution. I've also done work on an authentication suite called NetAuth and a ready-to-use turnkey distribution for booting Nomad directly on the metal called the Resin Stack. When I'm not busy annoying people with my strange uses of their software products, I am a site reliability engineer at a company called Backblaze. We keep far too many hard drives spinning, and if you find yourself on Reddit, we are the people who post the hard drive metrics quarterly. So we're talking about going from zero to prod. Now, before we can get to prod, we need to define where zero is. If we don't start all on the same page of where we're going to be building from, it's hard to get to the end. So zero is going to be defined as our machines are physically racked. We've already got them out of the boxes. If you've never ordered real bare metal servers, you might be surprised how much packaging they come with. So we've already got them out of the box. They're already in the rack. And we're going to say our layer 2 network is up. Now, the layer 2 network here could be as simple as just having a bunch of switches plugged in. We don't need the fancy traffic control plane yet. We don't need the additional routing capability yet. We just need the network up. And finally, we are going to need some way to turn these servers on. Now, this could be an IPMI network. Maybe you're going to use Redfish. Maybe you have some kind of low-level automation. You could also send the intern down to the data center and tell them to push the buttons in the right order. And that's a lot faster and a lot easier to do. Now, we've set our starting conditions. Let's set our ending conditions, because if we don't define the ending conditions, we won't actually finish. I'm sure you've all experienced the project where you hit the last ticket in the milestone and, oh, one more thing, can we get that in the sprint? So for our purposes, being in production is going to mean three things. We're going to be running production applications. This sounds obvious, but I want to define it anyway. We're running an application that is either part of our core software stack or something that we want to be using the cluster for, not just having the cluster for the sake of having the cluster. Second, the cluster is stable. Now, sounds obvious, but when you're bootstrapping a system, that's when things go wrong in spectacular fashion. So the cluster needs to be up, it needs to be stable, and we need to be able to take parts of it down and back up and know that it will work. And finally, we are not going to allow any remaining bootstrap toggles to be set. And a bootstrap toggle is going to be something where you have a non-nominal condition enabled within your fleet. This might be you have default passwords. This might be you haven't enabled TLS yet. But it's something that you would not be willing to long-term go to production with. So we're not going to have any of that still set. Now, I can already feel the smugness. You do everything in the cloud. Why do you need to bootstrap bare metal? Well, there's a couple of reasons for this. First of all, don't forget about your disaster recovery scenarios, because those look shockingly similar to day zero bootstrapping. If things go sideways enough, in fact, you'll find yourself doing day zero bootstrapping during your disaster recovery. Similarly, if you want to do cost optimization and you're going to apply a scale through zero approach, where you're actually going to turn off all of your infrastructure when it's not in use, the bootstrap is kind of how you bring that back up. And of course, as we talk here at HashiConf about the hybrid cloud and the shared estate, where some things are in the public cloud, some things are in the private cloud, don't forget that you may have metal on-prem. Now, if you do already run bare metal, you may wonder why you should change. Why am I telling you something new? And the really big points here are just that, you know this as well as I do. Bootstrapping is annoying, it's time-consuming, and it's easy to break. If you put on your security hat for a moment, bootstrapping is also the perfect time to persistently compromise your fleet. If I can sneak something onto the machine before you baseline it, it may take you a very long time to notice what I've done. This is a good enough reason on its own, but when we talk about processes that are error-prone, it's really good to put the time and effort into standardizing them and making them something you can repeat long-term. because eventually your unchecked growth will lead to a system you can no longer maintain. And if you don't plan the downtime to maintain your system, it will plan it for you. So in order to shield some of the complexity and in order to have everything going, we're going to imply software. We're going to use Nomad as a bootstrap orchestrator. Now, what do I mean by a bootstrap orchestrator? Because we often talk about, shifting things left, shift things left, make it the developer's problem. Well, we're going to shift beyond the left. This is the infrastructure that powers our infrastructure. So we're going to think about this not like the servers that are running our applications, but like tools in a toolbox. If you've never visited a data center before, they're very restrictive about what you can bring in and what you can bring out. So it's often the case that you'll have a special toolbox that you could just dump out for security to see. Bootstrap infrastructure works the same way. It needs to be thin, simple, fast, something that you can look at and not have to think too deeply about. And that kind of brings us to the crux of this talk. What is the bare minimum we need to bring up the fleet? Well, we need it to be streamlined. We need it to be ruggedized. These are the qualities that we need to seek in this technology. We need it to be something that is understood, because you can't say, we'll just do what we did last time. And you can't say, oh, no, that's Joe's problem, because Joe may not be in the company 10 years from now. You have to write it down. You have to have a plan, and you have to test the plan. One of the things, though, that we are going to look for in bootstrapping specifically that you might not do in your day-to-day operations is what is the maximum parallelism we can achieve while executing tasks. In the day-to-day, we may not want to do 100 things all at once because of the risk of if something goes wrong. But during Bootstrap, when there's no customer traffic at risk, there's no data in the system, we can go fast. We can power everything on at once, at least up to the point that the power company calls you and asks you to please not. Now, obviously, you're here in this room, so you already know that Nomad is the answer to this problem. But let's go through why anyway. Bootstrapping is a time where you don't have your normal footprint. So it's low dependency. We have pretty much what you can bring in on a laptop. We need it to also be a light hardware footprint, because we're bootstrapping the real hardware. We haven't got that available yet. And it needs to be technologically bulletproof. This is something that we may need to hand off. And so it needs to be something relatively well understood, something that is easy for people to work with. Nomad really fits the low dependency bill nicely. It is completely self-contained. There is a single statically linked Go binary that you can drop in place and run. It has no external dependencies aside from basic operating system primitives. Now, I'm going to caveat that and say, if your Bootstrap is going to involve you running Docker containers or containers of any vendor, obviously the container runtime is now a dependency and you will need to install that. This is magic, but not that magic. Nomad also comes with a few tools that are nice when we're in the Bootstrap phase. We've got a rudimentary encrypted variable store. This is not nearly as sophisticated as Vault, and in fact, if you are going to use long-term configuration that you need secrets, you definitely should consider installing Vault. Similarly, Nomad has a built-in service catalog, but it is not nearly as sophisticated as consoles. And if you're going to do service mesh or any kind of data plane routing, you should really consider installing console once the cluster is up. Now, we need a light footprint. And we really need this light footprint because of the last point on this slide, that bootstrapping is usually iterative. And if your iteration cycles are too long, it gets really annoying to iterate. And in fact, it gets so annoying that there is a point where you say, why bother? Nomad is very light for this use case. In my benchmarking and in my test clusters, I'm consuming 135 megabytes of resident memory once the system is up and stable with the Bootstrap controller set. Additionally, the CPU for these Bootstrap jobs is fairly minimal. I'm going to say fairly minimal because it's extremely bursty. If you're turning on one machine, that's a much lower load on the Bootstrap controller than if you're turning on 1,000 machines. But remember, you can always play with the variable of time in order to even out your resource utilization. Nomad is passively stable as well, and this is really important when we talk about doing these kinds of bootstraps. If you've ever had to overnight in a data center before because things are going sideways, you will know what I mean when I say you want to put it in place, walk away, and have it still be there when you come back. This is not the time to be figuring out why you have a dozen crash loop back off errors firing. This is not the time to be figuring out why your orchestrator isn't orchestrating. It's tooling that is supposed to work for you, not the other way round. That sometimes I think we often forget as practitioners that the tools are supposed to help us. The last point on this slide is something I really want to call your attention to. If you don't work in bare metal, you may be unfamiliar with the turn-up process, especially if you're looking at turning up a resource in another country, perhaps a country where you are not authorized to work. Sometimes you will write the plan, you will come up with the workflows, but you are not the IC who will execute. You're going to put all this hardware in a crate, FedEx it to the other side of the world, and pray. So you need these processes to be well documented. You need them to be ready to operationalize. Now, I have thrown a lot of high-level ideas and concepts at you. So let's go through a practical example. Let's make this real, something that's a little easier to work with. So this job listing, this very small job listing, is everything you need to bootstrap a data center of bare metal from cold. This even includes some initial monitoring that allows you to keep an eye on things until perhaps your more complete APM suite is up and running. This can physically boot both machines and VMs, though if you are running VMs, you may prefer to work with a golden image workflow out of a tool like Packer. And these jobs and this listing are where the 135 megabyte number comes from. So you can run this on very small hardware. We've got a low resource footprint. Let's go through what each of these jobs do so that you have a better idea of why they're there and how they've earned their place in the bootstrap. First, we're going to talk about the things that have to happen for the bootstrap itself to even be usable. And you may be surprised to see TLS certificates at the very top of this list. But again, bootstrapping is the ideal time to compromise your environment. So we really should be doing things right from day zero. And that means we need to have certificates and our traffic flows need to be encrypted. We need to have a proxy layer that's going to terminate these encrypted connections, and Traffic works really well for that. It is natively aware of Nomad's service catalog, so we can just plug in. We're then going to have a container registry. This may seem like an odd thing to have in your bootstrap set, but you may be bootstrapping in an environment that does not have your full high-speed connectivity available. I recently assisted with a data center turnup where normally we operate on multiple 400 gigabit per second connections. But during turnup, we had AT&T Uverse in the building. And so on this tiny 1 gig per second pipe, we needed to bring the whole site up. Having containers and mirrored packages for your operating system cached locally is a massive quality of life improvement so that you can just start things and then go to dinner, rather than starting things and having to wait and watch and make sure they ran. The last item on there is TerraState. This is a daemon that is a very, very small Terraform state store using the HTTP backend. The only reason we're using a localized state store rather than relying on HCP Terraform is because of the same reason we have the container registry. We may not have the stable network yet, especially if your architecture calls for large-scale SDN or large-scale dynamic firewalls. We really need to bring everything with us. Now, once we've got this base infrastructure running and we're in a place where we can bring up the rest of our fleet, we're going to need to use some conventional tooling. This is nothing new. If you've been in technology since, well, the 90s, you've probably at some point encountered DHCP and TFTP, the Trivial File Transfer Protocol. DNSMask is a popular low-resource system, and this is capable of sending out what's called a DHCP addendum. And this allows you to not have to send quite the same level of network management into Nomad. We can still have our external system, be it a Palo Alto or an Arista or a Juniper box, that is managing DHCP on our bring-up subnets. This is only going to fill in the pieces that are needed to install the machine. We then have a tool called Shoelaces that's going to automate this so that you can just go running through the aisles pushing power buttons, and it will make sure the machines get the correct images. And finally, we're going to have an on-site mirror. Now, this is how I've bootstrapped my fleet. But there are other ways to do this, and I would encourage you very strongly to look at what your hardware supports. A lot of more modern hardware actually has some of these tools burned into the ROMs, and so you can skip steps here and have it come up even faster. Once the machines are up, though, now we need to add them to the cluster. This is, for me, always the most exciting part, because we go from a room full of computers to a single amorphous blob of compute that bends to our will. I do this with a technology called Ansible. Ansible is going to push to these freshly booted nodes. I'm using a tool called Ara. Ara records Ansible, because aren't recursive acronyms fun? And this is going to put Nomad on the machine and join it. Now, remember, one of our success criteria was that we don't have any bootstrap toggles left at the end of this. So the very last step of pushing this bootstrap is going to delete the user that pushed the bootstrap. There are some considerations when you delete the user you're actively running as, but you can make it work, and it keeps the fleet clean. Once we have the OS on, now we can do some really fun stuff. We can use Nomad to push Ansible. Now, if you've used Ansible for any length of time, you may be aware that its Achilles heel is that its execution speed is linear with the number of hosts in a given playbook. And once you go above about 1,000 hosts, it's painful. There's no way around this. There's tools that can help you with this, things like Ansible Automation Platform, but it's still slow. Now, we can use Nomad to improve this a bit. Once we've brought up our real server nodes, not just our zero-level bootstrap compute, we have a lot more resources at our disposal. And we can use that to do more things with Ansible that we'll get to in a moment. Now, at this point, you do have a choice. You're running, you have your base cluster up. You could detach the bootstrap compute. But consider for a moment, that is self-contained. It does not depend on the rest of your infrastructure. Wouldn't it be nice to keep that connected so that if something goes terribly wrong, you have a lifeboat to flee to where your most critical control plane services can continue to run? It's a lot easier to recover things if they don't go all the way down. Now, I talked about using Ansible for this, and if you've come to HashiConf before or you've seen my past presentations, you may have seen the one where I told you why you should not use Ansible and you should use Nomad instead. So I want to touch briefly on this. Ansible is an extremely widely deployed system configuration tool. It's very popular, it's been around for a long time, it's very stable. It is also really easy to make self-contained. If you're not aware of the larger tools in the Ansible ecosystem, there is actually a first-party tool for building containers that run Ansible and that pack everything up. All your collections, your modules, your files, they're all in that container ready to deploy. And finally, and this is very important for what we're going to do, Ansible is agentless. It connects over SSH or other transports. And this allows us to deploy it in a way that doesn't require us to bake it into the image of the OS at install time. This has security implications. I'm going to show you something very cool, but you have to promise me not to run with scissors. We're going to run Ansible in a container. This is going to allow us to deploy it across our entire fleet simultaneously as a system batch job. You can even run this on a cron job so that your Ansible is being continuously refreshed across the fleet. We're then going to create a bind mount between the host's file system namespace of its root mount point and /host inside of our container. There's no rule that says that the chroot has to be the smaller slice of the machine. So having done this, we can now have Ansible join the host's control namespaces chroot into /host and execute using the chroot connection plugin within Ansible. Now Ansible is running using Python from the container to configure the host. This is an incredibly powerful tool because it means that now by using system batch and the fact that these tasks are scheduling concurrently using Nomad, we are operating Ansible in constant time, regardless of fleet size. This allows you to do a whole lot of really impressive things, such as running your configs on webhooks and having them push almost immediately, having things test for drift detection because you're constantly refreshing your Ansible. It also allows you to not have SSH on your machines. If you are confident enough in your configuration management, you can stop SSHD because you now have another way to push your Ansible to that machine. And once you get to this point where you're able to push Ansible in this way, your bootstrapping and your maintenance are the same thing. Now, this is a huge win. Your bootstrap and your maintenance just became the same thing, which means your bootstrap processes don't go stale, your maintenance is more reliable, and you now have one fewer thing to maintain because you've amortized the effort over the larger process. This is really taking the long view in building out this kind of infrastructure and making sure that you have a long-term capability to maintain a fleet. It's my opinion that we're going to see more data centers in the near future and more bare metal build-out. The cloud is extremely nice to experiment with and play with, but long-term cost optimization is tricky to do when you're just renting the capability. Now, I've shown you how I did this, and I want to give you a little more information about how you can operationalize this knowledge in your own environments, because what you saw is not something that took a limited amount of time to think about. I've been thinking about this for the last decade. Don't worry, you can copy my homework. It will be linked at the end. When we're deploying this kind of bootstrap compute, this needs to be small. We're going to eschew the ideas that this is a rack-mounted piece of hardware from a major vendor. Because if you have never tried to bring a 4U Supermicro through the airport, the Transportation Safety Administration looks at you real funny when that's your carry-on, and the airline gets annoyed when you scratch the plastic on their overhead bins. So we need something small. We need to be really small, because we may be flying internationally with it. And we really are looking at a solution for the problem we have, which is bootstrapping enough compute that we can bring the rest of the data center online. So we're not looking to run all of prod. We're not looking to be high performance. We're looking to solve the problem in front of us, which is powering on just enough compute that we can bring the rest of the data center up with us. Some of you can already see where this is going, but consider the small form factor NUC. These are excellent small devices. They're low cost, so if one gets left at a data center, run over by a server lift, dropped through the baggage carousel at the airport, it's not a big deal. The one I've shown here is a GMK Tech NUC Box 5. Of course, many people make these now. This particular one is small enough to fit in your pocket. This is what the 135 megabyte number from earlier came off of. This is what I've been playing with to build the entire demo set. 12 gigabytes of RAM does not sound like much in this day and age. My corporate laptop has almost 100 gigabytes of RAM because I do a lot of work with VMs, and so 12 sounds small. But 12 gigabytes runs a very respectable number of bootstrap tasks. You can really fit a lot in there, especially when you consider that you can oversubscribe this memory during bootstrap. These are not services handling user-facing traffic. So if they crash and restart, it's no big deal. Wait a minute, they'll come back. Nomad will reschedule them for you. And really remember that this is not long-term compute. You can leave this connected. I'm not sure I would leave these connected. The power supplies run very hot. But it's not long-term compute. So we can do things here that might make the security people a little uncomfortable. We can do things here that are not the way we operate our standard data centers. But this is still a server. And serverless is so much fun. Is there a way that we can get rid of even the bootstrap server? Can we do this without that box? Well, it turns out, yes, we can. Most large, modern enterprise switches, especially things running at port speeds in excess of 50 gigabit per second, have substantial supervisory controllers. Arista, in particular, makes their supervisory controller available to the end user. It runs Arista EOS, which is a fork of the enterprise Linux ecosystem. It's also GPU accelerated due to the specific system on module they chose, which is always funny to me to see that my switches are GPU accelerated. But this means we now have enough compute that we can run the bare metal bootstrap on the switch. We've got everything we need to bring the data center up with no external hardware now. So where to go from here? Well, please go and build something with this knowledge. If nothing else, what I would ask everyone to do is to document your own processes. Future you will thank you. have some idea of what depends on what, and think beyond the server about what other tasks in your bootstrapping or onboarding workflows can be automated. And share your work, because bootstrapping is hard. If you'd like to follow any of the example implementation that I have here that I've shown you, you're welcome to go to this link, which has the complete Terraform, Ansible, and Docker sources to be able to duplicate my bare metal bootstrap. Pause for one moment for people to grab the QR code. And finally, I want to look at how far we've come. We started with a data center that had nothing in it. And then mere hours later, through the power of Nomad and pre-staging some software, we're all the way at a running site that is ready for us to deploy our production applications to and start serving live user traffic. There are people out there who will tell you that it takes months to bring a data center up. I used to be one of them. But with this workflow, I have brought that timeline down to comfortably the point that I can tell you 3 hours. If you've got 3 hours, you can bring the data center from cold and dark to revenue processing. It's just a matter of choosing to build the automation and then streamlining it for your organization. If you have any questions, do please feel free to write to me at maldridge@voidlinux.org. Thank you very much for your time. I'll be hanging around the hub if you have any questions and you're here in San Francisco.